Hello, we are Milli in the Volts. My name is Joel Gutierrez, and our project is called the Milli Locator. The Milli Locator is a pet tracking collar that uses energy harvesting as an energy source. In this video, we will be discussing GPS and Wi-Fi, solar panel and battery experimentation, tech experimentation, PCB design, and what's next in more detail. I will now cover GPS and Wi-Fi. Some of the goals we've been able to achieve with GPS and Wi-Fi are that we've been able to get GPS coordinates through an evaluation board via USB. These results have been looked at through a PC. The next step will be to receive the data from the GPS through cellular or Wi-Fi. Our next subject is going to be solar panel and battery experimentation. Jordan, take it away.
Thank you, Joel. With solar being our main energy harvesting source, experimentation has been done to test the actual physical characteristics and outputs of the solar panels and batteries and so forth, with a 50 ohm resistor being used as a dummy load. With the battery connected to the resistor load, the battery voltage was drained in about 2 hours as expected. Then with two solar panels connected in parallel, they successfully charged the battery to a voltage of 1.8 volts within the same time frame of 2 hours. Now, as the harvesting chip and GPS chip are added to the circuit, more accurate data will be collected, but these results show a reasonable extension of battery life is attainable depending on various factors. And now Kayla will talk to us about the TEG experimentation and PCB design.
Thank you, Jordan. So we conducted additional TEG tests, and this was specifically for dogs with longer hair. These test results were lower than our original result, and this was expected since the original test subject, Ivan, had shorter hair, which allowed the TEG to come into closer contact with his skin. Our new test subject, Steez, shown here in the image, he provided average results of 3.1 milliamps and 18 millivolts. And we are still considering the TEG as a valuable harvesting option to support the system when solar energy is unavailable. And in this case, it would just be providing a trickle charge to the backup battery. The next update is our PCB design. Version 1 of the Milli Locator PCB has been completed and ordered for testing. Some concepts for redesign include length and width modifications to better fit the size of the dog collar. We will also be reconsidering the sizes of capacitors C4 and C5 shown here in the image, and this is due to possible height constraints of the device housing. And any additional modifications will be brought to light once testing has begun. Next, Jennifer will be wrapping everything up.
Hey, thanks, Kayla. So our team's next steps are to finalize PCB design and send to print. We'll conduct tests when it comes back via breadboards. We need to connect this harvesting system to the GPS chip and wirelessly communicate coordinates to the user. And last, we need to complete the design and layout of the final prototype, including 3D printing of waterproof housing to protect the system. During design, the placement of energy harvesters and this housing will be crucial to make it durable enough for any dog's outdoor activities. So thanks for watching Milli in the Volts. We'll see you at the end of the semester.